Will La Nina return? Let's explore. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, June 29th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a special contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Tim Caston, Mont the Drifter, an anonymous donor, SW23831, and E. Slade. Thank you all very much. With that, let's get to work. First up, I'd like to take a minute and direct your attention to a feature that's running on SportsCenter Online for ESPN. It's called Ride of a Lifetime. It's about Alo Slibar and his potential world record-setting wave, the 100-foot wave at Mavericks that was ridden on December 23rd of this past year, 2024. He is featured in here. It's all about the wave, and there are a couple of faces that you might recognize from other places in there. So if you got a minute, just do a search, Ride of a Lifetime ESPN. It'll pop up on YouTube, and you can watch the segment. It's about 6 or 7 minutes long. Easily digestible, a lot of fun to watch, and very serious waves. All right, let's move on. We're going to start by looking at significant wave heights across the planet. As expected, North Pacific, very quiet indeed. North Atlantic has a little bit of activity. There actually was some swell producing energy there. We'll get into that in a minute. In the South Pacific, we see a gale with 25-foot seas pushing off to the north. That is generating a small swell that is headed towards California and Central America down into South America. We see another gale with 22-foot seas and another little patch of 22-foot seas and 21-foot seas in the South Atlantic, providing surf for Africa, but nothing over the top. And then a bit of a stronger signal here in the Indian Ocean with up to 29-foot seas. But notice, nowhere, anywhere are there 30-foot seas or higher, sort of suggesting that maybe we're in a bit of a quiet pattern for the moment. But before we get into all that, let's take a look at current conditions. We're going to start up in the Pacific Northwest at the border of Washington and Oregon. We're looking at the buoys, the Grays Harbor buoy, number 036 there at the end of the Columbia River. We're looking at all the energy that's hitting this buoy all the way up from 33.3 second period, very energetic, long period swell energy, which there is 0.0 feet of, all the way down to 5 second period, just pure wind chop, and we're about a half a foot of energy in that period band. You see, in general, little bits of southern hemi swell in there, but not exceeding half a foot in any band. And then wind swell, in the 8 to 9 second period range with 1.2 to 1.3 feet of energy in those bands. Put that all together, primary swell, 2.4 feet at 9 seconds from 287 degrees. That theoretically would make surf at about 2 feet. And then secondary swell, 0.8 feet at 13.7 seconds from the southwest, making 1 foot surf. So all in all, pretty quiet there. Then we go down to Northern California, Point Reyes buoy 029, just off of or just northwest of the Golden Gate and San Francisco Ocean Beach. Profile, about the same, but more amplified, more southern hemi swell here in the 14 to 15 second period range, and more wind swell in the 9 second period range. Primary swell, 4.6 feet at 9.2 seconds. What makes a primary swell? It's the integration of height and period, and whatever makes the largest surf is primary, and then the secondary is whatever is something less than the primary. So primary swell, 4.6 feet, 9.2 seconds from 320 degrees. 4 foot surf, pretty typical for the summer. Secondary swell, 1.8 at 13.7 seconds from 192 degrees, putting surf in at about 2.5 feet, or we'll give it up to waist high on the sets. Heading down to Southern California, the Point Loma South buoy off of San Diego there. all the wind swell blocked by the Channel Islands. Southern hemi swell still there, but already getting attenuated or just dying because of lack of size. Primary swell 1.4 feet at 13.3 seconds from 202 degrees, putting surf at about 2 foot. It says secondary swell 0.7 at 16. Yeah, I guess so. If you sort of look out in here, I don't know if that's really rideable swell. 0.7 feet at 16.8 seconds from 197 degrees. That would put surf at 1.2 feet. So pretty quiet there. Then finally over to the south shore of the Hawaiian Islands, we're going to the Lanai buoy, number 239. Small bits of southern hemi swell there, but you notice nothing even 1 foot in any one period band. Let's see how the algorithm does. 1.1 feet at 17 seconds from 191 degrees. That would make surf at about 2 feet or thigh high, which is, I thought I saw waist high SETSO this morning. And then secondary swell 1.3 feet at 13.8 seconds from 185 degrees. Again, about 1.8 feet. So all in all, a pretty quiet pattern across the main locales in our forecast area. So let's do a quick review of what has gone on in the various oceans over the past week since our last video, Sunday the 22nd of June. We'll put this into motion. I mean, we're in the North Pacific. The expectation, not a whole lot going on. We're pretty much moving into the peak, or not the peak, but the core part of summer, and we just went through everything there. You saw it, and literally nothing showed up. Then we go to the southern hemi. Here is that ice anomaly. There was a extratropical low falling south, and you can see it here, blasting down south. And bam, you see what it did to the ice anomaly? There was literally, I'll go back here. There was literally 50 knot winds, if you looked at the weather model, blowing from north to south, and it just mashed all that ice further south, chunks of ice. It disappeared and was gone. Now, you see there were seas up to 37.9 feet right here, the highest seas over this entire domain. But they were all aimed at the Ross Ice Shelf. Nothing was coming from that relative to California. But secondary low pressure did develop Wednesday evening, the 25th of June. You see a small area with 31-foot seas, kind of lingering in that area into Thursday, aimed pretty well to the north. That has produced swell that is pushing up towards California, Central America, and South America. For California, somewhere around the 4th of July weekend. And notice, as soon as the winds disappeared, chunks of ice started moving back off the Ross Ice Shelf and showed up on the model again. See, we're on Sunday. Another little low. Here we go. This one little low. This is even weaker low, barely 28-foot seas. Normally, I wouldn't even give it the time of day. But seeing how that's the only thing that's happening, a little small swell is expected from this as well, coming in late the 4th of July weekend into early on the work week past that. Then we're taking a look at what's happened over the past week in the North Atlantic. If I recall, let's see, I think there was a little something. There you go. It was at like 17-foot seas, building to 19-foot seas, building to 20 feet. That was as of Friday, the 27th of June into Saturday, pretty much sweeping into, or just north of Ireland and Scotland in that area into Saturday. So that swell has already passed. There's some other seas in about the 18-foot range developing off the coast as we speak. And going back a week for the South Atlantic, there was a gale south of South Africa with 26, almost 27-foot seas, 28-foot, you saw it there. A stronger gale developed right behind that on late Monday, the 23rd of June with 37-foot seas, but that swell has already hit and is gone. You see some energy wrapping up the southeast coast of South Africa. Another little gale developed on Saturday with up to 26.2-foot seas right there over a tiny little area. And it's doing the same thing that many of them have been doing this season, sort of hugging the coast, wrapping up. Good for Jeffreys Bay, but kind of wild and woolly, not particularly well-refined swell. And then finally, reviewing what has happened in the Indian Ocean over the past week. This has pretty much been the standout. A gale with 30-foot seas set up early Monday, the 23rd, actually building a little bit more into about the 35-foot range, not pushing to the north so well, but still you can see a swell front here, energy radiating north, and then push south of Australia. I think there was another one in here. Now, deep one, 36-foot seas. That was as of yesterday. Tracking more to the east, not to the northeast, but some sidebands. Well, you can already see it right here. Trying to radiate north, and then, whoop, and that pushing south of Australia. So there is activity, but nothing over the top. It is moving into July, typically the slowest month historically of the year, at least for southern hemiswell in California and Hawaii. Doesn't include there wouldn't be swell, but typically, historically, it doesn't bear out to do much. All right, so we're going to start looking at the future. What's coming up for the next week? We're going to start by looking at jet stream level winds. These winds up at about 30,000 feet help support the formation of gales when those gales form, help direct their track. We're looking for a trough. We see it right there. A push in the jet to the north. That helps create a clockwise flow aloft and down at the ocean surface. That is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface and generate seas. Those seas, as they radiate away from the fetch area, the lesser period elements fade off because they don't have as much energy, exposing the longer period swell. And of course, that swell, when it hits your beach, wherever it might be, generates surf. All right, so we have a trough. We know there was a gale there. It produced, 25-foot seas. That was like this morning sort of thing. So let's see what happens. My guess is, sure enough, that trough just starts collapsing as we even get into this evening. Now you notice the jet's actually diving south. That's a ridge. And you get the sense here you get a counterclockwise flow. The wind's going like that. Just follow the arrows. That would be high pressure. That does nothing to support gale development. We're continuing out. We're into Wednesday already. The jet running zonally west to east down to almost 60 south and weak and not, I guess you could kind of almost say that's a trough there, but not really. Whatever it was, it's pretty weak. And then you see here comes another ridge just sweeping across the deep South Pacific. The ice anomaly is right here. The ice line up at like 62 or 63. South, so really no support for gale development, and then the jet pushing right over the Ross ice shelf. As we get into Friday and Saturday, we'll just run this on out, 180 hours. No clear support for anything. If anything, look at this, how split the jet is. Lots of high pressure, no support for gale development. Get what you can. So let's go look at the effects of those of the jet stream and what it does to surface level pressure and surface level winds. We're going down to the surface. You see there is a low pressure system here in the Southeast Pacific producing 30 to barely 35 knot south winds. That's really not enough anymore to generate meaningful seas, and by Monday morning you see it's completely gone. Moving out, we see something that kind of looks like a gale with 40 knot winds southeast in New Zealand on Tuesday, but it quickly dissipates. More fetch behind that, but all this is aimed to the southeast. That's indicative of 2 high pressure systems in control, dominating the picture. Now notice there is a gale here with 45 knot winds, but it's right in the middle of all that ice and right near the ice line, so it's not going to get traction. Maybe once it gets exposed, no, even there. Same situation here, just no hope, no winds pushing northeast towards even Peru, Chile, Central America. So kind of a quiet pattern. Now here is a gale forecast. It's a week out. Don't believe the models, but 55 to almost 60 knot winds aimed north. The Dana Point is at San Diego about 118 west, so right along there. So we'll go back just a little bit. You see the fetch doesn't even really get organized till it passes east of the Southern California swell window. So if this materializes at all, this would be a Chile and Peru and maybe Central America kind of storm. Oops, and there we go. And that's the end of the model. But again, this is all out a week. Don't even believe that. More in about 4 or 5 days out. Take it with a heavy grain of salt. All right, what's the effect of those winds on the ocean surface? We're going to go the whole way around the planet. We're going to start in the South Pacific since we were looking at Jetstream surface level winds there. There's our current fetch, 12Z. This is really Sunday morning. There's our ice anomaly, 25-foot seas in the Southeast Pacific, and you see by Sunday evening, they just vaporize completely and they're gone. We'll roll this out again. You see patches of, 26-foot seas, but not long lasting, not aimed off to the northeast. No suggestion that any meaningful swell will result. We're into already Saturday. Notice so the ice line here, just eyeballing it, is about 62, and then the ice anomaly goes up to about 58. Notice the deeper we get into July, the larger the ice extent gets, the less area there is available for gale production here between New Zealand and the Ross Ice Shelf. So no wonder it becomes difficult for storms to get developed this time of year down there. And then here comes our gale, our storm with 41-foot seas. Does it get any higher? 44 feet. This would be over a week out, targeting, I'd say somewhere from about here down to here, all pretty much aimed off to the east. So South America storm only. Going up to the North Pacific now, one would not expect much unless some sort of, significant tropical activity is going. Wednesday, there's supposed to be something here south of Cabo producing like 29-foot seas. We'll see whether that happens. 78 hours out, that maybe is believable. Something here off Japan, but not a whole lot. But then you notice we get two systems as we get later in the work week into Friday. And, this model overhypes the seas, I think, on tropical systems, but it's something to watch, especially it's way too early in the year, and one would not expect, though we have seen a steady flow of gales pushing across the North Pacific. So it would be hard to believe that maybe one of these would get caught by the jet pushing off to the northeast. I don't believe it. That's pure fantasy. Normally that doesn't really happen till you get into, maybe the middle of August into September on an El Nino year, which it doesn't appear this is, but something to keep your eyes on. The North Atlantic. We had one gale with 20-foot seas just a couple of days ago. Is there anything more, any energy left lurking? Theoretically, yes, 20-foot seas south of Greenland on Thursday, the 3rd of July, and then pushing towards the UK, I guess I'll call it, and impacting there late Saturday, the 5th, into early the 6th. We'll see whether that really happens. I will say, though, that the North Pacific, or the Northern Hemisphere jet stream, has been fairly prolific. Somewhere in July is where it typically dies out. I mean, I'm not saying that what we're seeing is particularly unusual, but it suggests that winter is still trying to hang on a little bit. Down to the South Atlantic, let's see if we can get some real motion going here relative to Africa. We see seas 22 feet, 20 feet. Yes, that produces swell. There we go, 28 feet. Anything more? 31 feet. And we're into Friday, the 4th of July. So yes, for sure, swell could result for South Africa as we get into next weekend. We're 156 hours out, and secondary energy with 27-foot seas right in close vicinity to the coast a week out. So hope for South Africa. And then to the South Indian, or the Indian Ocean, not the South Indian Ocean. It's all the Indian Ocean. 30-foot seas southeast of Africa on Monday, but not getting much traction. Another gale winds up with 32-foot seas. We get anything more, and lifting off pretty well to the north. This looks like a good southwest swell for Indonesia for sure, and energy even pushing into Western Australia. A bit far away, but still, take what you can get. And then another system develops. Now look at this, pushing due northeast on Saturday, the 5th of July, with 30-foot seas, building to 33 feet, up to, that's about it, 33 feet, but aimed well off to the north. Another swell to complement the one just before it, and this pushing very close into Western Australia, Maybe some stormy inclement weather there, but no shortage of swell appears to be setting up. All right, local wind forecast. The headline in regards to wind has been nonstop northwest winds off the California coast north of Point Conception, and it appears that is still the case. Lots of wind swell we have. So let's see, Southern California would be right here. This is Point Conception, San Francisco up here, Cape Mendocino up here, and the Oregon, North California border. You see 20, 25, almost maybe a little 30-knot winds right there. Generated wind swell sweeping down the coast. Trades, not too bad for the Hawaiian Islands, 15 knots. That's as of today. So we get into Monday, gradient continues. Notice you probably get a bit of, it's not showing it, but a bit of an eddy flow in here, south winds. There's low pressure here. I mean, so it's heat low inland, high pressure out here, tightens up the isobars, makes the gradient. This is a standard summertime sort of thing. For the most part, the gradient has lifted north. That's good. It took its sweet time in doing it. And then trades for the Hawaiian Islands on Monday, about 10 to 15 knots. Tuesday, more of the same thing. Wind swell, no shortage, north of Point Conception. Trades, actually like 10, barely 15 knots for the Hawaiian Islands. Wednesday, the same. It almost looks like the gradient's going to start falling south later Wednesday. You see 15-knot winds building over central California. Trades light for the Hawaiian Islands. Thursday, nope, the gradient starts lifting north again. On Thursday, trades light for the Hawaiian Islands. Friday, now the gradient falls south, but noted its aerial coverage is not particularly big. Wind's not particularly strong. Sure, enough to just junk everything up. And right when we think swell's going to be arriving, trades building 15 knots for the Hawaiian Islands. Saturday, same sort of deal, 15, 20 knot northwest winds near shore and 20 knots off the coast. A fetch of east winds at 15 knots for the Hawaiian Islands. Saturday into Sunday, you see high pressure building in strong. Here comes the next gradient, just from Point Conception northward, a wind machine. And now trades return to the Hawaiian Islands solid at 15 knots. The PCT hikers forecast, the data is old. It's back from Wednesday, but you see the general pattern, just steady 55 to, I'll call it 55 to 60 degrees up at the intersection of the Pacific Crest Trail and Tioga Pass Road in Yosemite. That's up at about 8,700 feet. So what you see today is probably what we're going to see for the rest of the next week, which is pretty warm in the inland central California area, but at elevation, probably warm. I mean, I was looking at temperatures in the Tahoe area down at lake level, and it was 75, 78 degrees, something like that, in the parking lot at Squall this morning. So, or this afternoon. So, pretty warm down low, but cooler up high. Surf forecast for the Columbia River area there at intersection of Oregon and Washington, sorry. Surf heights, now notice this is off a little bit. It was hung. I went and looked at this. The server got hung up, so I fixed it. But I don't have fresh data for right now, but you get the general idea. Surf heights 2 to 3 feet, all basic wind swell with northwest winds on it. Swell heights 3 feet at 9 seconds, 3.5 feet at 7 seconds. Nothing significant forecast. We go to Ocean Beach, California, again dominated by wind swell in the 4-foot range, maybe going up to 6 to 7 to maybe even 8 feet as we get into the early part of next week. Local winds, not horrible, 10 knots out of the northwest. Swell heights, 7 feet at 8 seconds, 9 seconds sort of thing. No southern hemi swell forecast until we get later into next weekend. Southern California focused on Dana Point, same sort of deal. Whatever swell there is, 2 feet here, Friday, Saturday, Sunday, that's the southern hemi swell. That fading out, really nothing coming in to replace it. Swell heights, 1.3 feet at 13, 14 seconds. It was actually bigger than that. This is probably a just generic beach kind of sort of thing, not focused on any swell magnify or, any break with swell enhancing bathymetry. Then you get out into Monday, Tuesday, Wednesday, and we're 1.5 feet at 5 seconds, just pure, probably unrideable wind swell. South shore of Oahu, surf heights in the 1.5 to 2.5 foot range, and mostly I would say that's all going to be wind swell. Though I did look at some of the details. 1.7 feet at 15 to 15 seconds on Monday. There's your wind swell. 1.8 feet at 13 seconds Tuesday. So little bits of background southern hemi swell, but nothing significant. If you want real surf, you have to travel now. Jeffreys Bay over in the southeast coast of South Africa, surf heights. Sunday, 20 feet. That's off the coast a little bit. That's not like right at Jeffreys Bay, but that's the feeder swell. Dropping off into the 8 to 9 foot range on Tuesday, and then likely coming up. Notice the winds building. The quote-unquote clean swell just completely disappears. Let's see how this works out here. So swell heights, 15 to 16 feet at 13 seconds, dropping off into the 10 feet at 13 to 14 second period range, and then building back to 10 feet at 14 seconds on Wednesday, and likely going up from there. And then finally down to Bali, the focus, the magnet for all swell around the planet, it seems, or we'll say Indonesia in general. It's not just Bali, it's that whole area. This is just a sort of an indicator of what's going on in the area. You see surf heights 9 feet here on Sunday. That swell drops off as we get into Monday, Tuesday. Another swell arrives in the 8 foot range, and after looking at the models, we saw a whole bunch behind that likely. Swell heights today, 5.5 feet at 15 to 16 seconds. That drops off into the 13 second period range on Tuesday. Then Wednesday, you're back into 5 feet at 16 seconds. I would love some of that. Wish some of that would have happened in this area. All right, let's go take a look long term. We're looking at the two major weather oscillations that affect our weather. In the shorter term, the MJO, the Madden-Julian Oscillation, and in the longer term, ENSO, the El Nino Southern Oscillation. And this is where we're going to get into trying to tease out, well, is La Nina going to redevelop, or are we going to go neutral, or do the models just have no clue what's going on? So we'll go with the first part of the discussion, looking and examining the MJO, the Madden-Julian Oscillation. There are two phases to it, an active phase and an inactive phase. The active phase is our friend. It's like a low-pressure system. Both phases rotated around the planet, west to east on the equator. The active phase, there we go. The active phase on one side, inactive phase on the other. They rotate around the planet like that, opposite each other. The active phase, being our friend, and a low-pressure system, takes warm, moist air at the ocean surface, lifts it aloft. That energy gets caught by the jet stream, feeds the jet stream, makes it stronger, digs out troughs, and makes the jet stream more favorable for swell development. The inactive phase of the jet stream, well, it does the opposite. It's high-pressure, falling air that cuts off the flow of energy to the jet stream, making it weaker. Based on everything we've seen, just looking at the models, it seems like the active phase is somewhere over Africa into the Indian Ocean, because that's where all the focus of storm activity has been and is going to be forecast. And it seems like the Pacific is kind of cut off and in the inactive phase. But the models, at least mathematically, sometimes have a hard time figuring out exactly where it is. So sometimes you just got to, use common sense and look at the data and make your own best guess. So that's what we're going to do right here. We're going to start by looking in the Pacific. I mean, most of this forecast is going to be Pacific based because that's where I live and that's our main forecast area. But all right, we're looking at data from the TAO buoy array, a series of buoys strung across the equator in the Pacific used for monitoring El Nino. There are wind sensors on those buoys. This is the East Pacific here. This is the West Pacific here. There's New Guinea. That is the equator right there. That's the international date line, the far West Pacific. So I've been telling you it starts at 125 East, but I went and did a really close look at Google Earth and go, I think really the start of the East Pacific starts at about 130 East. Okay, so, and that's about where this is. And then the far East Pacific is just off Ecuador. It's actually off the end of the chart here a little bit, but pretty close. Ecuador is like at 80 West, so somewhere like there. We're looking at the arrows. The arrows are wind speeds. At 5-day average winds, the longer the arrow, the longer the winds. So pretty strong east trades over the East Pacific, pretty strong east trades over the Central Pacific, maybe not so strong east trades over the West Pacific. But it is not the wind speeds, what's happening now. It's how does this compare for every year for the past 30 years over each little tiny area of the ocean surface. And they've got tools to do that. You can see, the winds are a little bit stronger out of the east here, but not too bad. Almost neutral here, and we're just talking not even 5 degrees, 2 degrees north and south of the equator. And then in the far west Pacific, look at a little bit of westerly anomalies. I'm not saying that is the active phase of the MJO. Oh yeah, in the active phase of the MJO, because it's a low pressure system, trade winds are generated by high pressure systems. So if you have lower than normal pressure over the area for weeks at a time, it dampens trade winds. And that's kind of almost what looks like going on here. You get over here, trade winds are a little bit more enhanced. So this is just the Pacific Ocean, but it says as you maybe are pushing into the Atlantic, trade winds might be trade winds might be stronger than normal here, and maybe in the maritime continent, weaker than normal. I don't know. We'll see. Let's go keep digging here. Next up, 850 millibars zonal wind anomalies. This is the east-west component of the wind. Are the trades blowing stronger than normal or weaker than normal? The blues indicate stronger than normal trades. Out of the east, the oranges and the reds, they call them westerly anomalies, but it's effectively weaker than normal trades. All right, but this is for the whole planet. Let's get ourselves oriented. So there we go. 180, that's the international date line in the Pacific Ocean. The far east Pacific starts at not 125, but 130 east, we'll say. So right about in there, okay? And the Pacific ends over at 80 west, so somewhere around here. But really, it's that area from the far west Pacific over the date line to about 70 west. That's what really matters, because if you have westerly anomalies there, they start feeding energy into the jet stream. That then gives the jet stream momentum to make its way across the Pacific intact. All right, so actually today, here's where we are. It's actually the 29th, but you get it. Westerly anomalies made a incursion almost to the date line, but by tomorrow, that's supposed to fade. Easterly anomalies again set up, but as we get into just past the 4th of July, around the 7th or 8th, notice westerly anomalies are to be knocking on the door. They're at like 140 east, building to about 155 east as we get over, this is just over the next 2 weeks, suggesting that, if anything, I don't know if I'd call it the active phase of the MJO, but whatever is producing these eastern anomalies, and if you look at this, they've been just howling. This is really the La Nina signal, if you will, the remnant La Nina signal of our Modoki La Nina that's been over the Pacific for a year now, since the last, I'll call it a moderate El Nino. So we'll get into that a little bit more, but the hope is that during La Nina, okay, you have a dominance of easterly anomalies. During El Nino, you have a domination of westerly anomalies over the date line. The idea is to get westerly anomalies as far up to the date line or as far into the Pacific as possible. That way you get better support for jet stream feeding energy and storm development, both in the north and southern hemis, and also for the production of rainfall into California in winter months. If you're in the active phase of the MJO and you're getting upward moving, warm, moist air, it's eventually going to hit the upper atmosphere, up at the jet stream level, condense, turn into clouds. So these models just tell you, well, are there going to be more clouds on average than normal? The blues, cloudier skies, the oranges, weaker sky, or clearer skies, falling air or rising air. Let's look at our chart here. South America, Central America, New Guinea, the equator right across there, date line right there. Each of these panels is out 5 days. So this goes out today, 5, 10, 15 days. So about 2 weeks from now. This is a statistic model, and it basically shows this would be the active phase of the MJO. Very weak indeed. This would be like the inactive phase somewhere over here. Shows really no MJO signal at all for the next 2 weeks. Whatever we have today is about all we're going to get. This is not unusual for this time of year. The dynamic model, the GEFS model, says, Oh, but wait, hold on. We're going to give you a solid active phase of the MJO 2 weeks from now. Do I believe it? Probably not. But, you know, it's something to sort of hold on to and hope for. Here's the phase diagrams for those two models. The statistic model, dynamic model here. The MJO moves from west to east, from the Indian Ocean to the Maritime Continent, to the West Pacific. Did I say east to west? West to east is what I meant to say. Indian Ocean to the Maritime Continent, to the West Pacific, to the East Pacific, under the United States, over the Atlantic, back to the Indian Ocean. It's just both of them. Where this chart just maps the active phase, wherever the active phase, the inactive phase is on the other side of the planet. So with a heavy dot is where the active phase is. So somewhere over the East Maritime Continent, almost trying to get into the West Pacific. But according to this, if you're inside this circle, it is extremely weak. And there's 1, 2, 3 lines in here. Those are the forecast members. They say it collapsing to, I'll call it the West Pacific. So all but dead over the West Pacific 2 weeks from now. The dynamic model, though, says, well, that same thing. But then notice here about the second week of the model run, it pops out in the East Maritime Continent and outside of the circle. So weak active phase 2 weeks from now. So a little bit of disparity between the models. That's pretty normal. The 40-day upper level model. So this gives you sort of a better sense of planetary-wise where the active and inactive phases are. This is 5 days a panel, goes out 40 days. The oranges and reds, dry air, the greens, wet air, so active phase, inactive phase. And South America, Central America, New Guinea, 0 is the equator, date line right here going the whole way down the chart. So this shows some sort of a weak active phase somewhere between Africa and the very far West Pacific Ocean, which is pretty much what we're seeing because all the storm development really, it starts somewhere right here under Africa, gets ramped up pretty good in here, then peters out as it pushes under Australia into the Pacific, with the inactive phase centered over the Americas. All right, this model has been almost showing some exact version of this for 2 months now, and it doesn't change. That being because the active and the inactive phase are just very weak, and you know, this is kind of the active phase is home by default. If there is no real forcing, that this is like the standard model for the planet. Anyway, if the active phase were to wake up, according to this, it would move into the Pacific, which it would somewhere in mid-July, and then over to the Americas, while the inactive phase, a true inactive phase, sets up in July and into early August. We'll see what happens. All right, let's look at a model going out a month. This is the CFS model. It's a dynamic model. Here is past performance up here. Here's the forecast down here. Date line. This is for the whole planet. Date line right there. Far West Pacific at 1:30 East, so right about there. Our main area of interest is right around in here. This model too shows westerly anomalies building. You know, today they're over the equator across the Pacific. They fade a little bit of easterly anomalies for 5 days, something like that. And then westerly anomalies build, reaching over the date line as we get into the early part of July. Then that collapses and some sort of easterly anomaly pattern sets up enhanced trades. And you see the dotted contour here, the inactive phase of the MJO. But what you really notice looking at this chart, if you know what this chart normally looks like, there is MJO is the black contour. These are not even serious MJO indicators. We've had an extremely weak MJO since April, and that pattern looks to continue for the next 2 weeks. And then the CFS model going out 3 months. The forecast is up here. Past performance is down here. Now, here's where things get interesting. We've been talking about, well, is La Nina coming back? Let's talk about the forecast and see where we're going. All right. So dateline runs right up the middle, far West Pacific at 1:30 East. So right about there. Okay. And you notice westerly anomalies here, easterly anomalies in the East Pacific, starting south of Hawaii and then onward from there. And if you just look up here, you see westerly anomalies holding from just about the date line. Let's see, I don't draw a line right there. Yeah, maybe just a little bit east of the date line, starting today for the next 3 months. That's a very good sign. The good news is you want westerly anomalies over the West Pacific because as the jet stream moves from west to east across the Pacific, this is its energy source to feeding it. Now notice there's easterly anomalies here like south of California and south of Hawaii, but the jet stream theoretically should already have momentum as it passes over this area of westerly anomalies. It's getting soaked with moist wet air, and that should push it through the Gulf of Alaska as we get into the fall months and help support storm development. Okay, but also notice easterly anomalies pretty solid. This is last winter's pattern where the easterly anomalies were over the date line. This puts them more like over California. This would be like high pressure here, and we'll see this in a minute. And then the high pressure moves closer to the coast while low pressure is out over the Pacific. Let's overlay the MJO here. Let's get okay. So here's your weak MJO pattern. Literally one isobar or one contour MJOs are pretty much no MJO at all. Notice this strong active phase of the MJO forecast as we get, well, the Pacific starts right about there, so I'll call that the end of July. Another month of nothingness forecast. No forcing, but after that, things take off to the races. Notice here, again, a weak inactive phase of the MJO. So here we are today, weak active phase, westerly anomalies, weak inactive phase. Westerly anomalies continue, though. That's a very good sign. And then we're in a much better place once we get into the first week of August. Let's overlay the low pass filter here. So this is the low pressure, high pressure bias. Dotted contours, like right here. This is the La Nina signal, high pressure. It was on the date line with 3 contours. March, it was even, I think it was a little bit stronger than that, but it was really the peak of La Nina from a pressure perspective. That Modoki La Nina was like in January, February, which is very late for a La Nina. So its hangover is hanging on. But you notice as you get 1 week, we'll give it even, maybe the 10th of July, the high pressure bias really just chokes off and breaks down. Notice the low pressure bias here is starting slowly to ease to the east. It's like right on the front door to the West Pacific, trying to make its way in, creeping its way in as the high pressure bias gets weaker. I noticed this, though. I didn't see this. 2 contours here as we get into September, but also 2 contours of low pressure bias with the dividing line looking to be about 165 east. Again, we're believing a model 3 months out, but talking to what the title of the video is about, what are we headed for? And it looks like we're truly headed for this mixed bag signal of like almost a weak La Nina signal in the West Pacific, a weak El Nino, a weak El Nino signal in the West Pacific, a weak La Nina signal in the East Pacific. Okay, sort of a split pattern. I guess you could call that neutral, but you can make some inferences from that too, especially regarding precipitation into California and also surf generation. I mean, if you have westerly anomalies here in the West Pacific, the jet stream is going to be doing pretty well, getting good forcing across the Pacific. That likely could support storm development. In terms of rainfall, the east anomaly pattern makes me think that the jet streams, we could get like a Modoki La Nina that's like centered over the U.S. West Coast, maybe, blocking precipitation and snow, while at the same time, the low pressure bias feeding storm development, surf production. I mean, it might end up being a tremendous, perfect offshore winter in terms of winds with lots of swell, but not a lot of rain. We'll have to see on that. Let's keep digging. So that sets us up for the La Nina El Nino portion of the discussion. To start that off, we're going to look at subsurface temperature, water temperature anomalies. Data from the TAO buoy array, but instead of looking at the surface, these are the anchor lines on the buoys. The X's are sensors strung down those anchor lines. The sensors pick up water temperatures, and then a model fills in the gaps in between. We're trying to look at where the balance of warm water and cold water is. Cold water in the east is La Nina. Warm water in the east is El Nino. So right now, we're in a kind of a dead pattern, right? The 29 degrees centigrade isotherm, it was at 180 last week. It has backtracked a bit. The 28 degree isotherm, 28 degrees centigrade, was at 157. At one point, it was at 155 a couple of weeks ago. It has backtracked a little bit, suggesting again that maybe some flavor of the inactive phase of the MJO is over this area, increasing trade winds, push or sequester warm water over in the West Pacific. But it is not the actual, here's where things get really kind of interesting. It is not the actual temperatures that matter. Again, it is, drum roll, the anomalies, difference from normal for this time of year. And you're looking at this pattern here. This is the upper 150 meters. They call it the thermocline. We have normal water temperatures, 1 degree above normal, 2 degrees above normal, filling the entire thermocline. So this sort of suggests at least neutral, if not an El Nino-ish type pattern. Okay, we have no cold water left in the East Pacific. We have no cold water in flight. It's all warm water the whole way across here. Let's go look at another chart. This is the same chart enhanced with satellite data, okay, and it is even better in terms of where the warm water is. I mean, you see the West Pacific here full. This was right outline, that contour there. This was all colder than normal water. Now, and even a week ago, last week, it was still much more cool water than today. And this contour is above normal temperatures, suggesting that temperatures are warming in this area. And notice it almost looks like a Kelvin wave pushing east. Warm water driven by westerly anomalies reaching to a point, almost to Ecuador, certainly somewhere past the California coast. This is down on the equator with pockets of warm water east of there into Ecuador. And warm water off of all the equatorial East Pacific. So this suggests warm water is in control at depth. That is a very good sign because this is the indicator of what's to come a month or 2 or 3 months out. It might not show on the surface, but at some point, it all ends up being driven to the surface. Next up, Pentad sea level anomalies. This is the satellite data that just shows you, is the height of the ocean higher than normal? That is, strip out the waves, the wind waves, the tides. Is the sphere of the ocean, is it higher than normal or lower than normal? Why does that matter? Well, if you have cold water at depth, cold water contracts. And if it contracts, it'll displace a divot on the ocean surface. Warm water at depth expands, and it'll create a bump on the ocean surface. So let's get aligned here. Chile, Peru, Ecuador, the Galapagos Islands. There's the equator. There's the date line there. There's New Guinea there. Just 5 degrees north and south of the equator. And what's happened here just in the past 5 days, the expanse of, these are not temperatures. They are 0 to 5 degrees, 0 to 5 centimeters above normal sea surface height, inferring that there's warm water at depth here. Same deal here in the West Pacific. There's New Guinea. But what really caught my eye was the warm water making an incursion here over the date line. Then, boom, these 2 little dots showed up. Now, it's not a lot. It's no big thing, but it is suggesting that there is some sort of warm temperature or warming subsurface water making its way across the equator. We still have these minus 15, minus 20 there, and a minus 15 centimeter here. So a cold pool here and here. They're just barely outside the 5 degree north and south lines or right on it. So it is kind of a mixed bag, though it seems like from this in favor of warming, which is in favor of, I'll call it neutral, not in favor of La Nina. Then you can take all that and overlay it on a histogram, gives you a year's worth of data here. West Pacific here, East Pacific here. Here was our Modoki La Nina last year. Colder than normal temperatures in the East Pacific. The date line runs right up the middle here. Building warm temperatures as we got into January, February, March. That's pretty, with cold water here, that means trades pushing off of Ecuador here, creating upwelling, and then taking whatever warm water is normally in the equatorial Pacific and pushing it into the West Pacific. But now all of a sudden you get the sense trades have failed. Look at this, a wall of warm water, not super warm, but, we'll call it a half a degree, pushing over the date line south of Hawaii. And now you see it building almost the whole way across the Pacific. Neutral temperatures there and there, but generally looking much better and at least neutral, if not something biased a little bit warm. So that is all temperatures to come. That is warm water in reserve working its way towards Ecuador, eventually going to upwell to the surface, right? What's going on the surface? All right, so here we go. South America, Australia, New Guinea there, the equator right there, dateline right there. We only care about 5 degrees north and south of the equator. Now, this is corrected water temperatures. That is, they've kind of goosed it a little bit or actually tried to tamp down the temperatures a bit because the planet's getting warmer than normal. And so everything is lit up warm, and you see it here. And that's even after they've tried to knock the temperatures down. But just using this as our baseline, warmer than normal temperatures, 5 degrees north to south of the equator in the west. Now, this area in here, which was blue, colder temperatures a couple weeks ago, is all going warm. And now we almost have continuous warming the whole way across the equatorial Pacific, save for a couple little pockets here and there. This is not part of the equatorial sea surface temperature regime. This is, you can see it, high pressure right here. Underneath the high, no winds at all, so surface temperature is warm. They create those northwest winds. The high pressure creates northwest winds. We call them trades relative to California. I call it chop builders. And you see that pattern here. This is pretty normal for the late spring, even early spring. I'd like to see this fading out, but my guess is we're about 2 or 3 weeks behind, maybe even a month behind schedule. So it's going to hang around for a while. Either way, equatorial Pacific looking pretty good. Sea surface temperature anomaly for the past 7 days. South America here, you see warming temperatures. This was previously cooling. At least for the moment, things are warming. You also get the sense, just kind of interesting, that trades maybe have dampened some sweeping down the Baja coast because temperatures are warming all in there. This is not absolute temperatures, just is it a little bit warmer, a little bit colder than normal for the past 7 days, not even for this time of year. Okay, and otherwise you see kind of a neutral to slightly warming pattern over the equatorial Pacific. Now here is the alternate sea surface temperature anomaly, a different way of trying to tease out or get rid of the warm signal in the planet's oceans. So they just take sea surface temperatures all around the planet, throw it all in a bucket, average it together and say that's the baseline, and then let's explore the anomalies from that baseline. That shows a much cooler pattern here, a very La Nina-ish looking pattern over the equatorial Pacific. I mean, pretty much a what I'd call a La Nina pattern. Not super strong because you see there's still neutral stuff going on here. But warm water balled up in the east, in the west, cooler water in the east, all indicative of stronger than normal trades in this area. And then going out 15 days, you see this is, again, the sea surface temperature change, not 7 days out, but 15 days out. You see, yeah, sort of this mixed bag of cooling and warming. Kind of hard to tell exactly what's going on here. If anything, things pretty much staying the same. Here's the sea surface temperature trend for the Nino 1.2 region. This is the area right there by the Galapagos and Ecuador. You can see, and 0 is right here. Today's value right there, plus 137 thousandths of a degree above normal. So 1/10 of a degree above normal. Where have we been for the past couple of weeks? Well, we were almost, I'd say, 1/3 of a degree above normal. Then recently, as we got into June, things kind of dropped off and we basically averaged normal, and that's still where we are. I would attribute this to some weak inactive phase. This is probably the weak active phase. Let's go look at the official El Nino monitoring region. The Nino 3.4 region, the area out there from just south of California out to about the date line, 5 degrees north and south of the equator. Today's value, 141 thousandths of a degree below normal. So neutral is plus half a degree to minus half a degree. So basically we're neutral, biased, slightly cool. Weekly sea surface temperature values corrected for the Nino 3.4 region right here the last week, June 18th. 0.2 of a degree above normal. Again, this is corrected. So we've got multiple things going on. We have a weak MJO happening. We have corrected data versus uncorrected data. We have a global warming pattern and attempts to try to sort out how do we take that out of the signal so we can more cleanly expose the El Nino or La Nina signal. So all that is sort of combining. This says we're a little bit warmer. I'd say it's probably a tenth of a degree or two above normal. Even at that, we're still at neutral. Then finally, the Southern Oscillation Index, the difference in pressure between Darwin, Australia, and Tahiti. What we're trying to do here is determine is pressure higher in the Pacific Ocean than normal, which would signal or indicate La Nina, or is it lower than normal, indicating El Nino? So when pressure is lower in Tahiti, over here, and higher over Darwin, the index goes negative. That's what we want to see. Today, the index plus 2.81. You see we've been positive for, 6 days? 1, 2, 3, 4, 5, 7 days. Okay. But then we were negative for 7 days before that. Where were we a month ago? We were at plus 25. Today, plus 2. I don't know. Kind of hard. It sort of smells of neutral. So let's do a 30-day average. Plus 2.59. Where were we a month ago? Plus 2.16. Yeah, we went up a little. This is when the inactive phase is in control. Now maybe we're fading a little bit, suggesting the active phase. So this is your active-inactive phase indicator, and it's very weak. No big surprise. The 90-day average is your La Nina El Nino indicator, plus 2.97. Okay, where were we a month ago? Plus, I'll say 5.14. So in general, it looks like pressure is coming down in the Pacific. We're just a smidge above neutral. I mean, anything, to say you're in La Nina or El Nino, this has to be at at least plus or minus 12 sort of thing. And we're not anywhere close to there. All right, so here is the Southern Oscillation Index value graphed out. The normal graph I show, something's going on, so I can't find it. But you see let's see, here is the 90-day average. It's tracking down. Here is the 30-day average. It's tracking down, approaching neutral. So no real help from the Southern Oscillation Index either. So here is, let's see if we can get the amplitude of the MJO. Basically, is the MJO stronger or weaker than normal? When it pushes up high here, stronger than normal. When it goes down here, much weaker than normal. Where are we? Here, April, May, June, July, almost non-existent. One standard deviation, nothing happening here. You see we've done this before in July. This was in 2023. It happened again. I mean, seasonally, you can look back and say, yeah, it happens all the time in July. Some years stronger than others. But this suggests to me that if anything, and you see there was no big spikes this past winter either, that perhaps we are in a kind of a very weak atmospheric momentum kind of position right now. And then looking at cloud cover over the dateline. Here's the dateline here. The oranges and reds, drier than normal air. The blues would be cloudy skies. Here was our La Nina signal back October, November, December into the spring. There's a little bit of a dry signal currently set up on the dateline. You see the building wet signal right at the hairy edge of the entrance to the West Pacific, but not particularly strong. The question is, where is all this going to go? So we look at sea surface temperature forecast from the Nino 3.4 region. Okay, and that gives us a clue. Neutral is right here. April, May, June, July. Into July, neutral water temperatures. And then this suggests, boom, water temperatures falling to 0.8 of a degree below normal. That neutral is half a degree below to half a degree above. So this smells of Modoki La Nina for once we get in September, October, November, and December. Now, this is the raw data. The corrected data here still shows temperatures 0.6, maybe 0.65 or 0.7 a degree below normal. So the weakest of weak Modoki La Nina pattern. We showed this last week, but last week's consensus forecast, neutral is right there. You see the half degree above to below. And the majority of the models suggest some sort of neutral ENSO pattern going into this October, November, December, January, February. Biased, maybe cool by 2 to 3/10 of a degree, which shouldn't make any difference at all. So, what's it going to be? Well, first, let's take a look at current conditions. We have one swell, southerly angled swell relative to California and for Central and South America, pushing north, another tinier one behind that, and after that, the models show absolutely nothing. We're moving into the dead zone of the doldrums of summer, if you will, and that looks like it's going to definitely play itself out. We are in a very weak MJO perspective, no strong MJO signal at all, suggesting no meaningful momentum in the atmosphere for the moment. And then we start looking out, well, long term, what do we think is going to happen? Are we going to be ENSO neutral? Are we going to maybe a weak El Nino, or are we going back into La Nina? Really the CFS model is the main one that's saying a weak, I'd call it a Modoki La Nina that's east-based over the East Pacific. The flip side of that is westerly anomalies over the West Pacific feeding the jet stream. So if I were to have to make a guess right at this moment in time, and we're not even into July, I mean, I'd honestly say I don't even think we're out of the spring unpredictability barrier yet, because we still have these nuking trades or strong northwest winds blowing down the California coast. This is typical of springtime. I'd say the models aren't really sure what's going to happen. Whatever real verified signal there is, be it sea surface winds, sea surface temperatures, and I won't go subsurface temperatures, outgoing long wave radiation, it all smells as neutral can get. The thing in our favor is warm subsurface water temperatures continually building across the Pacific, and that is an early warning of what's to come months out. That looks very favorable. We have the CFS model, on the other hand, somehow saying that water temperatures are going to drop. I don't know where all that warm water is going to go. It's going to have to be one heck of a huge easterly wind burst setting up in August to basically nullify the momentum that that's been building in the ocean. So it's a very mixed bag signal, and there is no clear answer at this point in time. And I would say part of the confusion is we still literally are in spring. It feels like it. Yeah, we have surf, but there's a lot. We haven't, the flip side of that is, yeah, I say summer doesn't even start till July 4th in California, at least in Northern California anyway. So who knows? We're going to have to see. Let me know your thoughts. It's through talking to you all and hearing your opinion that always gives me good food for thought and helps me come up with a new way to approach the video every week. So I appreciate your contribution to the cause in that way. All right, so that's the video forecast for this week. If you enjoyed it, please give us a thumbs up. It helps the algorithm. If you have a comment or question, write it up down below. Also, please subscribe to the channel. That helps a lot too. Hit the Stormsurf icon down in the lower right-hand corner of your screen. And if you have a dime or two sitting aside and you'd like to make a donation to help support the Stormsurf cause, you may hit the super thanks button down below, the heart with a $sign in it. With that, we are signing out for this week. We will see you again next week, same time, same channel. Take care.